Hello everyone, welcome to my channel Sharda Devi Maths Classes. Today for class 9th I am starting chapter 1 Rational and Irrational Numbers. It is a very interesting chapter. We can understand this chapter together. We have already studied rational numbers. However, we can discuss those matters. What are natural numbers? Natural numbers are nothing but the counting numbers and it is the set of numbers from 1, 2, 3, etc. If we include 0 also to these natural numbers, we get whole numbers. Whole numbers are denoted as capital W. So, whole numbers is a set of numbers from 0, 1, 2, 3, etc. Now, what are integers? Integers are denoted as capital I or Z. That is the set of numbers etc. minus 2, minus 1, 0, 1, 2, 3, etc. The negative natural numbers 0 and natural numbers. What are rational numbers? Rational number is a number in the form P by Q, where this P and Q are integers and this Q, denominator Q, not equal to 0. Rational number is usually denoted as Q. This clearly we can say that natural numbers are elements of whole numbers. Whole numbers are elements of capital I, that is integers. Integers are elements of rational numbers Q. So we can say that rational numbers greater than integers and which is greater than whole numbers and which is greater than capital N. Now what is a fraction? Fraction which is a number in the form A by B, where this A and B are natural numbers. Every rational number Q is expressible either as a terminating decimal or a repeating decimal. In other words, we can say that every terminating or repeating decimal is a rational number. So, we can say that rational number Q, that is the set of all terminating or recurring decimals. For example, if you take 1 by 2 which is equal to 0.5, which is a terminating decimal, whereas if you take 1 by 3, that is the same as 0.333 etc., which is repeating decimal. This here 1 by 2 and 1 by 3 are rational numbers because they are in the form P by Q and Q not equal to 0. Thus, rational numbers are either terminating or repeating decimal. That is the set of all terminating or repeating decimals. If you have a decimal like 0.999 etc., how can you represent this? You can represent this as 0.9, 1 dot above 9 or 0.9 dash. Again, if you have 0.232323 etc., you can represent this as 0.231 dash or 0.23, 1 dot above 2 and 3 each. Again, if you have another decimal like 0.54, 27, 27, 27 etc., here this 54 is not repeating. So, you can represent this as 0.54, 27 alone is repeating. So, 27 dash or 0.54, 27, 1 dot above 2 and 7 each. If you have a rational number without doing actual calculation, how can you understand that it is a terminating one or not? For that, if this P by Q is a rational number, this Q can be expressed as 2 raised to m into 5 raised to n. Then we say that the rational number is convertible into a terminating decimal. For example, if you have a rational number say 5 by 8, how can you understand that whether this is convertible into a terminating decimal or not? You just factorize this 8 so that you can write this 8 as 2 into 2 into 2. That is, this is 2 raised to 3. This can also be written as 2 raised to 3 into 5 raised to 0 because this 5 raised to 0 is 1. So, this 2 raised to 3 into 1, same value you will get 2 raised to 3, that is 8. Both are same, that is this 8 can be represented in this form 2 raised to m into 5 raised to n, where this m and n are whole numbers. So we say that this 5 by 8 is convertible into a terminating decimal. What are irrational numbers represented as Q dash? Irrational numbers are the set of all non-terminating and non-recurring decimals. That is Q dash, irrational numbers, that is a set of all non-terminating and non-recurring. Both conditions should satisfy. If you have a decimal like 0.231567 etc., here we cannot predict the pattern in which it is formed. All are different. So this is non-recurring decimal, but at the same time it is non-terminating. So both conditions are satisfied. So this is an irrational number. In the same way, root 2, root 3, root 5, pi, etc. are also irrational numbers. They are also non-recurring and non-terminating. Now what are real numbers? Real numbers are represented as capital R. Real numbers are the union of rational and irrational numbers. That is, real numbers R is equal to Q union Q dash. Now we can do exercise 1A. First question is 0 a rational number? Can it be written in the form P by Q, where P and Q are integers and Q not equal to 0? A 0 is a rational number. 0 can be written like this: 0 by 1, 0 by 5, 0 by minus 7, like that we can write. So it can be written as 0 by 1 etc. in the form P by Q, where P and Q are integers and Q not equal to 0. Second question is, are the following statements true or false? First one is, every whole number is a natural number. So here we know whole numbers is starting from 0, 1, 2, 3 etc. whereas natural numbers from 1, 2, 3 etc. So this 0, which is a whole number, is not present in this natural number. We can say that the given statement is false because 0 is a whole number but it is not a natural number. Second statement is, every whole number is a rational number. When a whole number starting from 0, 1, 2, 3 etc. these can be represented as a rational number, 0 by 3. So we can write the answer as true because every whole number P can be expressed in the form P by 1 and so is a rational number. Now the third question is, every integer is a rational number. Integers are starting from etc. minus 2, minus 1, 0, 1, 2 etc. Each of these can be represented in the form P by Q, where Q not equal to 0. So the statement is true because every integer m, if this is m, that can be expressed in the form m by 1 and so it is a rational number. Now the fourth statement is, every rational number is a whole number. We know rational number can be natural numbers, whole numbers, integers, all these are included in the rational number Q. But every rational number is a whole number is not true because if you take a rational number, say 2 by 3, it cannot be a whole number because whole numbers are starting from 0, 1, 2, 3 etc. So this is not included in the set of whole numbers. So we can write the answer as false because every rational number P by Q, where P and Q are integers and Q not equal to 0, that cannot be a member of whole number. Now the third question is, arrange minus 5 by 9, 7 by 12, minus 2 by 3 and 11 by 18 in the ascending order of their magnitude. Also find the difference between the largest and the smallest of these rational numbers. Express this difference as a decimal fraction correct to 1 decimal place. So we can write the answer as, first of all, the given rational numbers minus 5 by 9, 7 by 12, minus 2 by 3 and 11 by 18. We cannot arrange in ascending order directly because their denominators are different. So we can find the LCM of the denominators. Here the LCM is 36. So we can make the denominator of each of these as 36. So the first one is minus 5 by 9. We can make this 9 as 36 by multiplying the denominator with 4. Numerator also at the same time we have to multiply with 4. Then the second one is 7 by 12. With 12 we have to multiply 3 to get 36 LCM value. So the numerator also to be multiplied with 3. And the third one is minus 2 by 3. Here we have to multiply with 12 to get 36. So the numerator also with 12. Now the fourth one is 11 by 18. 18 into 2 will give you 36. So numerator also into 2. Now this can be written as minus 20 by 36, 21 by 36, 22 by 36. Here in all these cases denominators are same. So we need only to compare the numerators. That is, we have to compare these 4 numbers only. To arrange in ascending order, that means we have to find out the smallest one at first, that is minus 24, then that is less than minus 20, then that is less than 21, then 22. 22 is the largest. So this implies that minus 24 corresponding rational number is minus 2 by 3, which is less than minus 20 corresponding one is minus 5 by 9. Now which is less than 21 corresponding rational number is 7 by 12. Now which is less than 22 corresponding rational number is 11 by 18. So on arranging in ascending order we get minus 2 by 3, minus 5 by 9, 7 by 12 and 11 by 18. Now the second part of the question is find the difference between the largest and the smallest of these rational numbers. Largest is 11 by 18 and the smallest is minus 2 by 3. So their difference means 11 by 18 minus 2 by 3. So this is equal to LCM, that is 18. So 18 by 18, that is 1 into 11 is 11, minus into minus is plus, 18 by 3, that is 6, 6 into 2, 12. So this is equal to 23 by 18. So this is equal to 1.26. Now again in the question it is asked to express the difference as a decimal fraction correct to 1 decimal place. So this can be corrected as 1.5 or above 5 can be corrected like this, 1.3, that is the value correct to 1 decimal place. So this is the answer. So the fourth question is arrange 5 by 8, minus 3 by 16, minus 1 by 4 and 17 by 32 in descending order of their magnitudes. Also find the sum of the lowest and the largest of these rational numbers. Express the result obtained as a decimal fraction corrected to decimal places. So we have to write the rational numbers at first. 5 by 8, minus 3 by 16, minus 1 by 4 and 17 by 32. Here the denominators are different, so we can't arrange directly. We have to find out the LCM of the denominators. So here the LCM is 32. Now we can write this 5 by 8. Here we have to make this as 32, multiply denominator with a 4, numerator also with 4. Then second rational number is minus 3 by 16 into 2 we have to do. So into 2 in the numerator also, then that comma minus 1 by 4 into 8 into 8 in the numerator also, 17 by 32. 32 is the same. So this is 20 by 32 minus 6 by 32 minus 8 by 32 and 17 by 32. Here the denominators are same, so we want to compare the numerators only. So let us write this as 20 minus 6 minus 8 and 17. So, now corresponding rational numbers we have to choose. After arranging these numbers in descending order. So, the largest one is 20, then 17, then minus 6, then minus 8. What are the corresponding rational numbers? 5 by 8, now which is greater than 17 by 32, which is greater than minus 3 by 16, which is greater than minus 1 by 4. Here also like this, they are greater. So, this is the descending order of arrangement of rational numbers. Now, the second part, that is here we have to find out the sum of the lowest and the largest of these rational numbers. So, lowest is corresponding to minus 8, that is minus 1 by 4, and largest is 20, corresponding is 5 by 8. So, the sum of minus 1 by 4 and 5 by 8 we have to find out. So, minus 1 by 4 plus 5 by 8, LCM is 8. So, 8 by 4 is 2, 2 into minus 1 is minus 2 plus 8 by 8 is 1, 1 into 5 is 5. So, this is 3 by 8, 0.375. Here we have to correct it to 2 decimal places. So, 3 places we have to take. The third one is 5. So, we have to add one value here, 0.38 we will get. Correct to 2 decimal places. Fifth question is, without doing any actual division, find which of the following rational numbers have a terminating decimal representation. First question is 7 by 16. Here terminating decimal representation means denominator can be represented as 2 raised to m into 5 raised to n. Here m and n are whole numbers. Let us find out the factorization of 16, that is 2 raised to 4 will get it. So, this 16 can be represented as 2 raised to 4 into 5 raised to 0. 5 raised to 0 means 1. So, 2 raised to 4. Only prime factor of 16 is 2. Therefore, 7 by 16 has terminating decimal representation. Now, the second question is 23 by 125. Here this 125, it can be factorized. So, that 125 can be written as 5 raised to 3. So, this in this form 5 raised to 3 into 2 raised to 0. So, this 23 by 125 has terminating decimal representation. Now, the third question is 9 by 14. So, on factorizing 14, we get the factors of 14 as 2 and 7. They are the only prime factors of 14. But for this rational number 9 by 14 to be a terminating decimal, this denominator 14 has to be expressed as 2 raised to m into 5 raised to n, where m and n are whole numbers. But in this case 2 and 5 are not the factors of 14. So, the rational number 9 by 14 has no terminating decimal representation. Fourth question is 32 by 45. On factorizing 45, we can see that the prime factors of 45 as 3 and 5, but not 2 and 5. In order to express this in the form 2 raised to m into 5 raised to n. Therefore, the rational number 32 by 45 has no terminating decimal representation. Now, the fifth question is 43 by 50. 50 on factorizing we can see that prime factors of 50 are 2 and 5. So, the denominator 50 can be represented in the form 2 raised to m into 5 raised to n. So, 43 by 50 has terminating decimal representation. Here this 50 can be expressed as 2 raised to 1 into 5 raised to 2. That is 2 into 5 raised to 2. So, now the sixth question is 17 by 40. 40 can be factorized. So, the denominator of the rational number can be written as 2 into 2 into 2 into 5. So, this is equal to 2 raised to 3 into 5 raised to 1. So, this in the form 2 raised to m into 5 raised to n. Therefore, 17 by 40 has terminating decimal representation. Now the seventh question is 61 by 75. 75 can be factorized. So that this 75 can be written as 3 into 5 into 5. Here the prime factors of 75 are 3 and 5. There are no prime factors 2 and 5 in order to express the 75 as 2 raised to m into 5 raised to n. Therefore, the rational number 61 by 75 has no terminating decimal representation. Now the eighth question is 123 by 250. Here the denominator 250 of this rational number can be factorized, so that we can write this 250 as 2 into 5 into 5 into 5. That is, the prime factors of 250 are 2 and 5. So that this 250 can be expressed as 2 raised to 1 into 5 raised to 3. Therefore, 123 by 250 has terminating decimal representation. Okay, thank you very much for watching the video. Practice the problems more times. If you like the video, please thumbs up, share the video to your friends and subscribe the channel. Soon I will come back with the next video. Till then, bye bye.